No other spacecraft has been where we're going. We have never been to Pluto before. New Horizons will be the first spacecraft to show us what Pluto is like. But we've also never had a spacecraft that has gone beyond Pluto into the Kuiper Belt with the capability to observe Kuiper Belt objects and tell us about them once it gets there. The New Horizons spacecraft has extra fuel on board so that we don't use it all up flying past Pluto. We'll have a significant amount left that will allow us to fire our engines after the Pluto encounter is over and deflect the spacecraft to head towards whatever Kuiper Belt object we've found by this telescope search. It's not a lot of fuel compared to the speed at which we're going, and so we can just nudge the spacecraft a little bit. So really this is the first time we've been able to go up there with a properly equipped spacecraft for this kind of work, knowing what we're looking for. And with luck we're going to give humanity its first view of what those typical thousands, hundreds of thousands of objects out there are like, and what they can tell us about the origin of the solar system and what has happened to the solar system since they were formed. So we are here specifically to find the next destination for the New Horizons spacecraft after it fulfills its prime mission by flying past Pluto and telling us about the Pluto system. This is a really important part of the New Horizons mission that we're doing here right now. After we fly past Pluto, we want to explore the rest of the Kuiper Belt. Pluto is one of the largest of this vast swarm of objects, about 100,000 or more objects orbiting the Sun beyond Neptune. And it's a really amazing and fascinating member of the Kuiper Belt, but it's not one of the normal, ordinary members of the Kuiper Belt. We want to know what the rest of those guys are like as well. So we want to go out beyond Pluto and fly past one, or if we're really lucky, maybe even two other Kuiper Belt objects, smaller, more representative objects, somewhere out beyond Pluto. Subaru is really a perfect instrument for this job. It's a very large telescope, one of the largest in the world, and that means that we can look for very faint objects. And we need to look for very faint objects because New Horizons only has a small amount of fuel for changing its trajectory after it leaves Pluto. And so the small objects are very faint, therefore we need a big telescope to go chasing them, and that's what we're doing here.
Hawaii is the best place to live. So Subaru telescope is located at a mountain of 4,000 meter height, and island Hawaii is on the center of the Pacific Ocean. So with very small turbulence and with very clear skies, Hawaii is one of the best place for the astronomical observation.
So nature pulled this trick on us that one patch of the sky where we have to look happens to be right in the middle of the Milky Way, where there are the densest star fields of anywhere in the sky. So we're looking for a few faint moving objects, and what we see is millions of stars crowding the field. And they make it pretty hard to sort out where these little tiny faint objects might be. So that just makes our job more interesting.
First, we need to find the good candidates. For this purpose, we need a wide field and a very sensitive observation. And the SuPrime-Cam is an ideal instrument to do this observation. And CCD is a size of this size.
We're using the SuPrime-Cam camera on Subaru because it's a really wide field camera. You can see a big chunk of the sky at one time. We need to cover quite a large area of sky because we don't know exactly where these objects are going to be until we find them. And so the more sky we can see at the same time, the better use we can make of the telescope time.
What we were doing is we were installing John's instrument, which was called the SuPrime-Cam, and in order to do that, we had to first remove the instrument that was already on the telescope. What we did was you first saw the disconnecting of the wires. The unit loader then goes and picks up the instrument, lifts it off the telescope, moves in position for the Great Wall, hands it over to the unit loader. The unit loader then rotates 90 degrees and stores it onto the unit selector. And that's what it takes to remove the instrument. To install it, it's kind of the reverse process. Once the instrument is actually on the telescope and secure, the unit loader then transports the day crew person over to the side where he then connects the wires. And in the case of SuPrime-Cam, Because of its complexity, the person then has to go actually to the top of Suprime Cam. The scientists then make sure all the connections are okay. We then disconnect the umbilical from Suprime Cam, actually attach it to the fibers that are attached to the telescope, and then that process is done. Then they're ready for nighttime observers. John's going to come up and see something nice.